Okay, everybody. So for this last question on the homework, I wanted to bring in some COVID data. I've been wrestling with this back and forth because although we're smack in the middle of COVID season, um, the data is so incomplete. I was a little nervous about bringing it in, but then I had an idea. I had an idea when I started thinking about the magnitudes of two different data sets, and I think this might be a good time to A, bring them in, B, practice making scatter plots, C, show how to do some correlations, both graphically and also in Excel. And D, maybe even have like a ray of sunshine at the end of all of this. So we'll try to hit all four of those things. As we go through. Okay, so first off, I downloaded this data. It's currently April 15th, which in a normal year would be tax day. And it starts, I downloaded this data from the CDC. The first case of COVID-19 showed up on the 21st of January in the US. And I've got data all the way down through yesterday, April 14th. As a matter of fact, I started this data set yesterday, and since yesterday, about 22,000 or so more cases have shown up. And we've had some more people die from COVID as well. And we're going to talk about that in a second. So the first thing I want to do is I want to look at the data set of total cases as a function of date. So what we're going to do, left click on date and hold it, drag over to total cases, and then drag down so you highlight all the data. This is just like we did with the braking distances in the videos we watched for the first part of this lesson. Okay, then we're going to insert a scatter plot, which is this guy right here. And there it is. Now, before we go any further, I'm also going to scooch this graph to the top. Notice how it's down the bottom. I'm going to left click and hold the graph and start scooching it upward. And it's going to start kind of creeping a little bit slowly there. We're through March and February. I probably could have scrolled before I dropped the graph in, but we're there now, so it's okay. All right. Now, what you can see, I'll pull the graph a little bit to the right so you can see it better. That's you'll get a few more dates that way. You can adjust things like axes on scatter plots, just so you know. Like, for example, notice this goes up to 700,000, which I don't really mind that it goes to 700,000. You can right-click on an axis and then format the axis and have it change to different numbers. So you can, for example, change it to 650,000. And then you can change even the dividers that are being used. I can change that to 50,000. Okay, that looks terrible. I don't even like the way that looks. I just wanted to show you that you can. And I'm going to change it back to the way it was because I think the way it was actually better. There we go. Yeah, I like the way it looked originally. You can also change the axis. I'm not going to, based on what I just did, I'm not going to change this one, but you can also right-click and format the axis here. Okay, this is using Microsoft Excel date codes. I would ignore that if I were you and just be happy with the way it is. Okay, so this is probably a graph that you're used to seeing, which is this. I've seen the word exponential floated in the news quite often. I would argue that it's not really purely exponential. It's actually a combination of other things, but I don't want to get hung up in that. I do want to change this title. Total cases is not very good. Let's talk about COVID-19 data in the US. And the reason I'm saying data is we're going to add a few more data sets to this sheet. Okay. This is going to be numbers of people for sure. Let's put that. I'll put that label on there. We'll just put an axis title that's vertical, primary vertical. This is going to be numbers of people. Okay, and if you don't like it rotated like that, we'll format it and we'll make it just like we did in the video. We'll make it horizontal so it's a little bit easier to see. Maybe pop it up here if you want. Maybe make it bold. I don't think the dates need a description. I think they're fairly self-descriptive. Yeah, self-describing, I guess. Make this bold and a touch bigger. Okay, I like that. I like it so far. So far, so good. Okay, now, a couple things to think about with this graph, and I'm going to show you some other cool Excel trickery. If you look at the beginning of this, it looks almost kind of crazy and ridiculous. It looks flat if you think about it. And that's only because the numbers here are so big compared to what the numbers here were. And one of the cool things Excel lets you do if you want is you can click on the graph and then it highlights the data that's being graphed here. If you want, you can actually bump the data back to about March 20th by coming down here and then bumping this up. And if I go back to March 20th with this, and then take a look at the graph again, you see that actually, you know, you've taken, now what one problem is that the axis here has not reset. It's still graphing to 700,000. So what we can do is we can actually bump the axis down. It looks like this is 100,000. So I'm going to bump it out to maybe, I'm going to stop at 25,000. What if we hit reset? Oh, there we go. It likes 100,000. I don't like that. Let's go to 25,000 with an increment of, say, 5,000. Okay, let's take a look at that there. Now, so you're starting to see that even early on, the shape of the data was kind of exploding upward. It's just that the hyper focus on all of the data up through April hides this curve because of the scale of the curve. If you want, we can even bump it back to, say, March 10th. And then refocus this to 5,000. Make this be 500, maybe. And notice, it's still got that shape. As a matter of fact, let's bump it back even more to 2,000. Maybe make it really pop. Hopefully you see what I'm doing here with the maximum. I'm just looking at the highest data point and then trying to pick a maximum value that gives it a little bit of space up here, but we can still see. So what you can see, hopefully, is you can see that the shape of the data, regardless of how far out we go, is kind of the same. It's got this bend to it where it's accelerating. We're going to talk more about that in the next lesson after data mining, which is exponential growth. Although this is not perfectly exponential, it's more exponential than anything else. So what I'm going to do is I'm actually going to now undo and get back to our original data set that pumped all the way out to April. I'm just hitting a bunch of Control Z's here, my friend. There we go. So now we're back to the original data set. And looking at this, you can see how it does appear as though maybe, I'm going to offer some hope here, but cautious hope, that maybe the virus is done doing the explosion vertically. Maybe it's beginning to be more logistic, which means it's tapering off. I don't want to put any stock in that statement because that tells us that makes us believe that our data is perfect, which it may or may not be. Okay, now back to this. Here's the way I would like to look at the data next. I'd like to bring the deaths into this chart. Okay, so click on the chart again, and just like we were kind of goofing around with sliding this thing up and down before, we're going to slide this over. Left click, hold, pull, and that will drop the deaths onto our chart as well. Okay, that'll drop the deaths onto our chart as well. Now, it's a little confusing down here with these zeros. I might go in here and actually delete some of these zeros so it's easier to see. There we go. You should probably do that too, because the numbers are so small and the scale of the graph is so large, it looked like there actually were deaths from January 21st up to March 1st, but there actually weren't. So go ahead and delete those zeros out. I'm glad we actually had those in so we could talk about them. That way it doesn't graph them a zero. Okay, and you know what? Before we do anything else, let's also add a legend. Let's add the legend. Yes, there we go. That's good. That's really good. Because now we see total cases and we see deaths. You don't have to do this, but I'm going to do it real quick and then undo it. I'm going to click on the total cases and delete it. There's the deaths. Notice how the deaths are down in the very, very small quadrant of this entire graph. It almost looks like a straight line. Well, slightly curvy. And again, let's go ahead and format the axis. Maybe bring it down to, I don't know why the maximum says 2,000. We'll say 50,000. There. Oh, let's get the negatives out of there too while we're at it. That's kind of silly. Minimum 0. Oh, I see why, because I didn't change this. My apologies. There we go. And notice it has an exponential shape, just like the cases do. But its exponential shape is much, much more suppressed than the total number of cases. And that's what I want to focus on right now. I want to focus on the recoveries. Here's the way I'm looking at it. If there were 42 cases, total cases, as of March 1st and 1 death, I'm going to call recoveries as the difference of 42 and 1. Because if one person died and there were 42 people infected, that means we've got 41 recoveries. I know it's not exactly perfect because the data isn't perfect and we don't know about these 42 people, whether they will die later or whether they will get healthy later. We don't know, but we're going to make an assumption that if you're in this column, you died, and if you're in this column, you recovered, and these two have to add to make that number. It's not perfect. It's not perfect, but it's going to be good enough for quick analysis based on imperfect data. So what we're going to do is we're going to click in the cell E18. We're going to type a new formula, equals. And then we're going to click on the 42. And then we're going to go minus. And then we're going to click on the 1. And what this is going to do is it's going to take the 42 and subtract the 1 and leave 41 behind. Okay, the reason I'm starting here is because we don't have any deaths to subtract off. And I think it makes more sense to just start where we have our first death, so we can make it binary. Either you died or you didn't. Okay, now we can drag this formula down. I'm going to show you a cool little trick here. You can drag by left-clicking that drag handle and pulling, but you can also double-click on that drag handle. And what it'll do is it'll actually autofill all the way down to the bottom. All the way down to the bottom, which is actually kind of cool. All right, now what I'd like to do is I'd like to add that data set into our scatter plot. So you know what to do. Grab, drag, highlight, let go. And there's recoveries. And the reason I wanted to do this was mine made recoveries gray, which is kind of fun. Recoveries is almost staying congruent with total cases. And that hopefully makes sense, because if you look down at the numbers of deaths, they are orders of magnitude smaller than the total cases. The recoveries are actually much closer to the total cases. So what I'd like you to now do is we're going to do a percent recovery, because notice how gray and blue here are very close. I want to see how close using percentages. So what I'm going to do is in cell F18, I'm going to type a percentage formula. We're going to go equals. We're going to click on the 41, and we're going to divide that by 42. What this will do is when we press enter, it gives us a percentage. What is 41 as a percent of 42? Well, it's 98%. Okay, and that's a little bit maybe misleading. I'm not a huge fan of using percentages with numbers that have a denominator less than 100, but let's drag that formula down. And let's let it actually become percentages of numbers that are at least 100. And you might notice something. These are extraordinarily optimistic numbers, because it means that even though the COVID cases are more and more prevalent, the vast majority of people are not dying from them. And that's why I wanted to kind of use this data. That's why I wanted to use this data for y'all. I wanted to give you like a ray of hope. Yeah, COVID's there. It's not going anywhere anytime soon while we deal with it. But also, let's look for the sunshine. Let's look for the lemonade with the lemons. We are studying it as a scientific culture. We're getting more of a handle on it. I know scientists all over the world are working on this. And based on very incomplete data, I'm tempted to feel extraordinarily positive about this. Okay, so hopefully you do too. hopefully. If not, feel free to send me an email and ask me questions and vent, whatever you want to do. For your submission, for the 4 points on this homework, here's what I want you to do. Pretty simple. I want you to left click in the formula cell where you got this 98%, so I can see the formula right here. Then I want you to take a screenshot of this entire thing so I can see your formula. I can see your graph with the legend, and I can see all this stuff right here. And then that's probably enough, actually. Then you're going to copy that screenshot and you're going to paste it into your document for your answer to number 3. And that'll do. Okay, my friends, feel free to shoot questions if you got them, and we'll talk to you soon.